All right, and if fractions is something that you struggle with, check out my previous video on just the basics of working with fractions. So let's look at example number 1. If we're going to add and subtract fractions, we need to use common denominators. So that means that we want our denominators to be the same. So we want to think to ourselves, what numbers divide evenly, do 2 and 3 in this case, divide evenly into? And the answer is 6. So we're going to be setting up a question where we have two denominators, both of 6, and we're going to change our fraction to make those equivalent. So if I was going to make 2, my fraction with a denominator of 2, into a denominator of 6, I would have to multiply by 3. And that means that I would also want to multiply my numerator by 3. You can't do different things. You have to do the same thing to each. So 2 times 3 is 6, which we already have. 1 times 3 is 3. All right. So 3 sixths is equivalent to 1/2. All right. We're going to do the same thing with a third. So if I wanted to change my denominator from 3 to 6, I would have to multiply by 2. And if I multiply my denominator by 2, I also need to multiply my numerator by 2. So 1 times 2 is 2. So to have common denominators now, my denominators are the same, my numerators are different, and that's fine. We are going to add this, and when we add fractions, our denominator stays the same. So I'm adding up sixths. So I have 3 sixths plus 2 sixths, so I'm adding my numerators, so altogether I have 5 sixths. Okay, let's do the same thing. Let's subtract fractions in this case. So I have denominators of 5 and 3. And 5 and 3 both evenly divide into 15. Now you could pick bigger numbers. You could pick 30, you could pick 45, but it's always the easiest to pick the smallest number that they divide evenly into. So let's set up our equation so that we have two denominators of 15 and they're subtracting. Okay. Now, if I want to change my denominator of 5 into 15, I would have to multiply that by 3. So that means I'm also going to do that to my numerator. I'm going to multiply by 3. So 4 times 3 is 12. So 4 fifths is equivalent to 12 fifteenths. Same thing for my fraction of 2 over 3. If I want to change my denominator from 3 to 15, I would have to multiply it by 5. And if I multiply my denominator by 5, I also need to multiply my numerator by 5. So 2 times 5 is 10. Now, when I subtract these things, my denominator stays the same. We're subtracting fifteenths. And I have 12 subtract 10 in my numerator. So that will leave me with a numerator of 2. Okay. Now we have to still remember that everything that we know still applies. So if I'm going to add a negative fraction, that's the same thing as subtracting. So I'm going to take another step and say 5 over 4 minus 2 over 5. Okay. Or you could keep that subtraction there as well, but just to kind of let you know that you might see questions like this. So when I'm looking at denominators, 4 and 5 both divide evenly into 20. Okay, so to make my denominator of 4 into the denominator of 20, I need to multiply by 5. And then I also need to multiply my numerator by 5. So 5 times 5 is 25. Okay, again here with subtracting 2 fifths, if I want to turn the 5 in my denominator into a denominator of 20, I would have to multiply that by 4. So I'd also need to multiply my numerator by 4, and 2 times 4 is 8. Okay, so now when I subtract this, my denominator will stay the same. All right, so I'm still going to have a denominator of 20, and I have 25 subtract 8, and so that will be 17. Okay, it didn't happen with any of these questions, but if you ever end up with a fraction where you can reduce it, you always want to double check that all of your answers are in lowest terms. And if you need a reminder about how to do lowest terms, you can look at my previous video of fraction basics. Okay, let's go on to multiplying. When we're multiplying fractions, we do not need a common denominator. The nice thing with multiplying is that you just multiply straight across. So for this, multiply our numerators together. 2 times 3 is 6. And multiply our denominators together. 5 times 4 is 20. Then we always want to make sure that we put this into lowest terms. So if we notice that our fraction, both the numerator and the denominator are even, we can divide both sides, or both numerator and denominator, by the same value. So here I'm going to divide it by 2 since they're both even. And in lowest terms, my fraction would be 3 over 10. So you always want to do that double check. Now, same thing, if we're going to be multiplying by a negative fraction, this negative sign, it means that the whole fraction's negative, but that negative sign either needs to apply to the numerator or the denominator, but not both. Typically, we'd like to put it in our numerator, so it would look something like this. Okay, so it doesn't, if you apply it to both the numerator and the denominator, you're actually adding a negative. That would make this whole fraction positive. Okay, so again, once we have our signs figured out, we multiply straight across. So 2 times negative 4 is negative 8, and 3 times 3 is 9. Okay, negative 8 over 9 is already in lowest terms. There's no value that divides evenly into negative 8 or 9, except for 1. So we can leave this. We know that it's in lowest terms. Okay, now same thing with C. So we have two negative fractions. So if I'm multiplying a negative and a negative, I know that it's going to be positive. So negative 1 times 2 is, negative 1 times negative 2 is positive 2. And 3 times 5 is positive 15. And that's already in lowest terms. Okay, now dividing is also simple. All you have to do is flip your second fraction and multiply. Okay, so for our first example, we have 2 over 5 divided by 3 over 4. So we're going to rewrite this 2 over 5 times, and we're going to flip this fraction. So instead of it being 3 over 4, it's going to be 4 over 3. And now we have a multiplication question, which we did just above. We're going to multiply straight across. So 2 times 4 is 8. 5 times 3 is 15. Do a check. Can we put this into lowest terms? We cannot, so this is as far as it can go. Okay, same thing here. For B, we have 7 over 3 times, and I'm going to make this negative 5 over 4. So again, the whole fraction's negative. That means it applies to either the numerator or the denominator, but not both. And once I have it written as a multiplication equation, I can just multiply straight across. So 7 times negative 5 is negative 35, and 3 times 4 is 12. And I often get students wanting to know if they should be putting this improper fraction into a mixed fraction. The answer is no. Usually once you get to high school, we don't work with mixed fractions anymore. So you want to make sure it's in lowest terms. In this case, it is, but you can leave it as an improper fraction. Okay, last example. So we have negative 1/2 divided by negative 2 over 3. Let's flip that second fraction and multiply. So 3 over negative 2. And multiply straight across. So negative 1 times 3 is negative 3. 2 times negative 2 is negative 4. And we always want to make sure that we clean up our signs. So if we have a negative in the numerator and a negative in the denominator, that's actually a positive fraction. So positive 3/4, and that's in lowest terms. Okay, so if you have any questions, please feel free to leave any questions in the comments. Don't forget to like and subscribe so that you don't miss any important videos. Thanks so much.